In this concept video, we're going to be talking about how to solve for sides and angles in a triangle that does not have a right angle. So if you're wondering about the right angle stuff and right triangle, that would be the previous video, the first part or the first video there. And this one's the second one, and we'll go over what happens or how we can go about solving for sides and angles when the triangle does not have a right angle. So we're given triangle ABC here, and you can see our naming convention. We have large or uppercase letters here for the angles, and we want to go ahead and label our sides with those lowercase. So opposite of B here would be B, opposite of A would be A, C would go over here. Same thing as in the previous video, same thing applies. That's the convention. So one big thing that we cannot do here is we can't set up our regular cosine, sine, and tangent ratios. We don't have a right triangle, or at least we don't know that it is a right triangle. We can do some other things though. So we have some other formulas. There's the law of sines, and the law of sines can be found by dropping an altitude here, and you can set up a few different relationships using those right triangles. An altitude, of course, would meet at a perpendicular. And what ends up happening is we have A over sine of the angle, A, so make sure that your letters agree, is equal to B over sine B, and that is also equal to C over the sine of the angle, C. You can also flip these as long as in the numerators you have here, or in the proper spot of the fraction, you need to have like all side lengths here. We wouldn't be able to say that A over sine A is equal to sine B over B. That would not work. So make sure whichever way you set it up, that you make sure that either the legs here or the distances are in the top, or if the distances are in the bottom, then both the sine of A and sine B or sine C needs to be in the numerator position. All right. Sometimes the law of sines cannot be used. There are some cases where it's easier, or sometimes you have to. And in case of a triangle where you knew all the sides, you wouldn't be able to solve for any of these angles. And so there's another law that we need to help us out, and that's called the law of cosines. The law of cosines is written a few different ways, but the premise is the same. So you can do A squared is equal to B squared plus C squared minus 2BC, goodness, times the cosine of the first letter there, cosine of A. So essentially this one kind of looks like here the Pythagorean theorem, although the A, B, and the C are sort of in the wrong spots. Maybe the B is in the right spot, but the A and the C should be different. But it essentially kind of the first part looks like that. Then we subtract 2 times these two guys just to the right of the equal sign, and then take the cosine of the beginning letter. And if we keep with this convention, we can actually write the other ones out as well. And so I want you to know that these work also. You could do B squared is equal to, and then we want A squared plus C squared here. See how all three of these are different? Then if we look at the subtraction part here, we've got 2 times, well, BC up here, and now the A is here, and the C is in the same spot, so this will be 2. That's supposed to be a C. 2AC, and then cosine of the angle of the letter that you started with here in the first spot. And we could continue this. We could do C squared is equal to, and now we're going to have, whoops, that could be an A squared. Let's try that. I suppose it wouldn't really matter if it was B squared plus A squared, but we'll just try to keep our letters in a row here. And then minus 2 times AB. And then we've got the cosine of the beginning angle here, cosine C. So either one of these will work, and it just depends which one's easiest to use. Perhaps you're solving for a side, and you'll need to utilize that. And once you find one of these sides or an angle, the rest of it you can use either the law of sines or continue with the law of cosines, or perhaps use that knowledge that all three angles must add up to 180 degrees in a triangle. Also note that you cannot use the Pythagorean theorem here. So I want you to think about that. I want you to think when you can use a formula and when it is not allowed. And so here, when the triangle does not have a right angle, or we don't know, we need to use the law of sines or the law of cosines. You cannot use the Pythagorean theorem. You can't set up your regular sine, cosine, or tangents. You can use these other relationships though to help you.